All right. So with 9-6, lots of building off of what we've been doing in 9-4 and 9-5. There's factoring involved, there's common denominators involved, all that good stuff. So up at the top, you'll notice I've kind of handwritten a note that wasn't on your original note sheet. Might not be a bad idea to jot that down just kind of as a reminder, because some of you like to start going cancel crazy a little bit soon. That would say, once you have an LCD, because we're going to have a common denominator for all of these, and build your fractions. Because see, some of you are becoming famous for building your fractions and then canceling them back out, which doesn't really do you any good. So once you have a common denominator and build your fractions, have that part done, then you can wipe out the denominator and just solve it like an equation. So really, the LCD is only going to help us to get to our original problem, to build our original problem and solve it. So find the LCD, build the fractions, wipe out your denominator. Now, while some of you are jotting that down, I'm going to make one other thing just to kind of give you a mental reminder. Okay, when you're finding an LCD, because some of you are still getting bits and pieces of this, okay, you're always looking at coefficients, numbers that aren't bonded with plus or minus first, to see if you have one of those that'll be part of your common denominator. Okay. Once you've done that, you go on the lookout for single variables. And if you find them, again, ones that aren't bonded with a plus or minus, we want the biggest one as part of our LCD. And then finally, our unique quantities, which we sometimes refer to as sets of parentheses. Okay? You've got to do all three of those things. And sometimes I have people trying to just jam them all together. And I'm like, no, one at a time, because that's the only way you'll be able to keep them straight. Something I've barked about before, I'll bark about again. I'll probably stick this back up a time or two again as we're going through here. But what our job is going to be, peel this back for a sec. I'll put it back. I'll put it back momentarily. Is to kind of work our way through. Now I know you're like, what's this little message over here? We'll get to this. So okay, first things first, on every single one of these, we need an LCD. So on number 1, what would my LCD be? Okay, my LCD would be 3x, because I look at my coefficients first. I see no plus or minus bonds anywhere. Well, it's 3 or 3. I wonder if it's 3. Yes. And then I have an x to the first, or just an x. Okay? Don't multiply them together. Don't make the exponent bigger. My biggest exponent's 1. So I'm going to go ahead and I'm going to build my fractions. I'm still going to keep my original values in my numerators, so you're like, this is looking kind of familiar. We've done this before. It's true. But remember, now, once I have this to build, the question is, what do I multiply my old denominator, x, by, to get to my new one, 3x? Well, I already have the x, right. I just need the 3. When I get to my second fraction, to get from 3x to 3x, well, I've got everything already. I don't need to put anything in there. If you wanted to put something in, you could put a 1, but it's not necessary. And when I get to my last building, I've already got the 3, but I do need an x.
So it's like whatever you're missing, just add it on?
Right, whatever I'm missing, I'm just going to go ahead and add it in there. Once I do that, once my fractions are built, I don't need the denominator anymore. I kind of just say, thanks for helping me out, get out of here. Because now I just take what's left, so 7 times 3 is 21, minus 1 equals 5x and solve it. So we'll subtract those and divide by 5. And I get to a solution. Now in these, sometimes you may get one answer, sometimes you may get two, sometimes you may get none. How do I know? How do I know, I got an answer here. Here's one thing I want to make mention of, and I'll slide this back over here in a sec. Now we get to see the secret message on the edge. Okay, when it says make sure to check your answers, we can't have a 0 in the denominator for an x value because that would be undefined. So you're like, okay, so if 0 in the denominator is bad, in our case in number 1, if I'd have gotten x equals 0, that would have been a problem. 7 divided by 0, that's not defined. But 4 doesn't cause that problem. Okay, I can do 7 over 4. 3 times 4 is 12. That isn't 0. So that's all we're basically looking at. That doesn't cause 0, it's good. Okay, it works. So again, not to sound like a broken record, and if there is something that kind of bugs you as we're going through here, going, wait a minute, say that one more time. Let's make sure we go back through and situate things. Look at your denominators here in number 2 for a second. The first question on denominators especially always needs to be, are any of those factorable? Yes. Okay. My last one is a difference of squares, x plus 2x minus 2. And you'll be surprised when you're doing these how often, if you can factor one of them, it miraculously just is the other two denominators. So, in this case, my LCD is going to be x plus 2x minus 2. You don't have to write it out to the side, no. I just like to do it so I kind of see what I'm going to be up to here. Okay. Get my initial numbers rolling here. So just like we did in number 1, once I get that set, again, my whole concept is old denominator to new. And I kind of like the check-off method here. Okay, I got the x minus 2. Whatever doesn't get checked off moves into my numerator. And if I'm not sure sometime, I always should be able to, not physically, but kind of mentally thinking through it, those x plus 2's would cancel, would get me back to the original problem. When I do the next one, I've got the x plus 2. Didn't check off the x minus 2, so that's what we'll work with. And then in my last term, I've already got the plus 2 and the minus 2. So that one's good to go. I don't need to add anything.
So do we just end it there?
So here, that all goes away. And now I'm going to distribute and I'm going to solve this. Because with that equals, we always got to be solving something. And since we're not going to be doing example 3, if you want to start working into this area, you can. So we'll do a little distributing here. So we've got 3x squared plus 6x. And then here that 1 doesn't do a whole lot for me. Plus x minus 2 equals negative 4. Anytime you get one of these set up and you have an x squared term, everything needs to end up on the x squared side, because that's the only way we're going to be able to factor it. So in this case, we've got 3x squared, 6x in another gives me 7. And if I bring that negative 4 over by adding it, negative 2 plus 4 is positive 2. So what we're going to do at this point is factor this.
Slide in the button.
Yep, that would work if some of you do the mental math, the slide and divide, whatever method you use. The whole denominator, all the denominator, all we use it for is building that numerator up. And once we do, don't need it anymore. So for sake of ease here, I will do the factoring for us. If you would slide and divide whatever method again you use, you'd get to the same thing. And at this point, I would take each of those quantities that have x and set them equal to 0 and solve them. Now again, if I'm going to go through all the time to check and get these answers, the least I can do is make sure that neither of them are going to cause a problem. So if I plug negative 1/3 in for x, well, negative 1/3 minus 2 isn't going to be 0, so that's all I care about. Negative 1/3 plus 2, nope, that's not going to cause a problem either. Okay. But what about the negative 2? Negative 2 minus 2, okay, that's negative 4. Uh-oh. Negative 2 plus 2, 0. That's a problem. That answer's no good. Okay, so yeah, because if you say there's 2 answers and there's only 1, bad. So for instance, if this were a test question, okay, let's say it's a 2-point test question, and you do all that stuff but you leave both answers, you're going to get whacked for one of the 2. Because again, that's one of those things you've got to take that 10 seconds to look real quick and make sure. So we want to make sure the denominator never equals 0. Yeah, if my x value makes my denominator equal 0, bad, not going to work. Are we okay so far? Besides the fact that it's a little bit long, are there any issues that are coming up that are just kind of like make you get your head here? Okay. So let's move up a little here. All right. If you have terms that aren't fractions, make them fractions for our purposes. So I'm going to turn that 12 and that 2 into fractions, because sometimes, otherwise you're going to even forget that they're fractions and you're not going to want to deal with them. It's going to be bad. So what's my common denominator going to be this time? 3x. Because we have the coefficient 3 and we have an x, okay? So again, and I know some of you will start finding shortcuts that you can do with this. And I am going to try and avoid teaching those because typically what ends up happening is I have people who definitely need to just take their time like this and build it, and they try to skip steps and it gets ugly. So I've got all my numerators back in. And you'll never guess what we're going to do. That's right. Old denominator to new. What do we need in the first one? 3. I've already got the x. I need the 3. Because again, whenever I do these, if I were to go back and cancel, which I'm not.
But don't we already have a 3 listed already?
Right, but that's not the question. The question is denominator to denominator. What's in the numerator already? That's not helping me build my fraction, because that's there already. What I'm trying to figure out what I also need up here, it's all about the denominators. So like here, okay, I'm going from 1 to 3x. Well, I don't have any of it. So I've got to take 3x with me. Same thing when I get to the other side of the equals. I'm going from 1 to 3x. Well, I don't have either of those. So I need all of it, the 3 and the x. But for my very last one, I'm going from 3x to 3x. I have everything already, so I really don't need anything. But if you just desperately want to write something, you can put 1.
So you don't count the numerator?
Right. The numerator, the original one will be there, but when I'm trying to figure out what else to put in there, right, the numerator doesn't come into play at all. It's just old denominator to new one. Once we build our fractions, thanks for doing business with you, denominator. Get out of here. And now we just simplify what's left. So 3 times 3 is 9 plus 36x. And that's 6x plus 4. And now again, we're back to Algebra 1 stuff. So I'm going to get all my x's to one side. Subtract my 9 over there. Then it's one of those detail things. Okay? If this were a test question, I'll guarantee somebody would write down the answer is -6. To which I'd bang my head and go, no, minus 1/2. What am I dividing by here? 30. -5 divided by 30 isn't -6. It's -1/6. Those are the little things you have to be careful of. Okay. And again, -1/6 isn't going to cause either of these to become 0, so it's good. Okay, I can make sure on that. That took me all of like 2 seconds maybe. So one more. I want to be sure up here, and then we're going to start doing some bigger ones. I know. What's my LCD going to be for 6? Okay, for 6, 2x. But yes, for those of you who did number 5, x plus 1 would be correct. Yes. All right. So again, old denominator to new. What do I need? I've already got the x. What do I need up in the numerator of my second fraction? An x, because I already got the 2. So I need an x. And what about my last one? I need a 2, because I've already got the x. Well, this is a fairly nice one. They do occur every once in a while. So 6 minus x equals 24. Uh-oh. Minus the 6 over, and be careful. You're not quite done. Divide by -1. And -18 does not make a denominator 0, so we are happy campers. Anything that causes the denominator to equal 0, that answer gets wiped out.
What if we don't have 1?
Then it is possible to get no solution on these. We'll answer that question down here in the next section. All right, we bump up here a little. All right, now we're going to start getting more answers. Let's see if that causes any issues here. All right, denominators, any factoring to do? Yes. Okay, it is critical. If you can factor the denominator, you need to do it. Because otherwise, this can get really messy. So, what's our LCD going to be this time? X plus 1, x minus 1. And again, whoops. And again, we're not going to be doing 8, so if you need a little bit of room, that's all right. And get my initial numerators up there. So once I have that, again, just like it has been, the whole idea is old denominator to the new one. Whatever I don't already have. So whatever doesn't get checked off goes. Now this next one gets interesting. Because you're like, wait a minute, that's one. That's all this stuff. So I need all that stuff. Yes. Yes, you do. But that will be easy to clean up here momentarily. And then my last fraction, I've already got both. That, well, maybe, maybe not. We'll see here in a minute. Okay, so we're going to distribute first. Now when I get to my middle part here, this is where we have to have some decent short-term memory. This was the factored out form of what? What was behind my scribble? X squared minus 1. So let's see. What's this going to be when I FOIL it out? X squared minus 1. So if I remember that, I can just, or if I don't scribble it out, that's true, I can just take my 2, or my negative 2 here, and distribute that. Okay. Side work, let me show. Side work on what's going on here. Okay, we just determined that x plus 1, x minus 1 is really x squared minus 1. We knew that back from our original here. But right now, I need to multiply negative 2 times this stuff. So if I take negative 2 and multiply it by the x squared minus 1, because if I FOIL this out, that's what I'm going to get back to. I end up with negative 2x, and negative 2 times negative 1 is 2. That's where this is coming from. Otherwise, some of you, if you're more comfortable, do what I just did here. Have a scratch piece of paper to the side or something where if you need to FOIL or multiply something back out, you can. Okay? But leave yourself some room on that, or get a little flexible like this. So, equals 14. So like we mentioned in that other problem we did similar to this, if there's squared terms, and there are, all your terms need to end up on this side. So we're going to combine our like terms. Only one x term here. But this 14's got to come over. So we're going to subtract it. And then we've got to factor what's left. So again, for time's sake, I will factor for you. Four and who?
Negative 4 and 3.
Okay, negative 4 and 3. Where did I go? Oh, yeah. And just like we did on the other one when we factored it, each quantity is set equal to 0 and solved. What's it? Uh-huh. And again, the only numbers that would cause me problems would be negative 1 or 1. I didn't get either of those as answers, so I'm good. So again, it's about details. I'll admit it, one slip up on a detail and you're basically done. And they're like, oh, speaking of done, 9, Hardy, we really have to do 9? Yes. Yes. Yes, we have to do 9. Yeah, amazingly, you remember when we had that x plus 1, x minus 1, and these things kind of just worked their way out? You'll never guess what this factors out to.
Oh, look at that.
They're like, oh, Hardy hasn't learned. He's still scribbling things out. It's okay. It'll work out for me this time.
Is it always going to be like that?
About 95% of the time it will be.
That's good.
So what I would always do is I would just quick foil this quick in my head to see, yeah, is that going to come back? Yeah.
Not that other 5%.
Could you do 3x plus 2 and x minus 2? Does that include that?
Yeah, you can have them in either order. So that's nice because now that basically just formed my common denominator for me. Gracious.
That's wonderful.
I ran out of It's like sideways on my I don't want
It's like sideways on your paper.
to
All right. Got the x minus 2. Need the 3x plus 2. Got the 3x plus 2. And yes, Blake, to answer your question, yes, we are going to need to FOIL this time. And I have everything in the last one.
I was going to say.
Yeah, I thought my first word was going to go with
So, all right, let's try to clean this up a little bit. First fraction's no really big deal. Now, just a suggestion. When you get to the next part, okay, here comes the Hardy side work again. Let's just give everybody a package of Post-it notes to work with.
I was ready to say that. You should.
Okay, foil it, box it, whatever you do, okay, to multiply this out. But before I deal with that negative, I need to get this cleaned up first. So once I do whatever my foiling is, however that all works, that's strictly multiplying these two things together. But I still have the minus that's out there lurking. So when I go to rewrite this, and I'm just going to move it a little bit to the left, so don't think I'm taking it completely away here, okay? I've got a negative 4x squared, a positive 9x, and a minus 2. And luckily for us, there's still nothing to do on the right side. Once I get to here, everything's heading to the left, because that's where x squared is. So 6 minus 4 is 2. Am I gutsy enough to do this? No, I'm not. 4 and 9 is 13x. Okay, minus 2. And I'll actually move it all together here on this next step. Me and skipping steps usually don't end up working out well for me. Subtract over the 17x, subtract over the 4. Before I hear the word slide and divide come out of anybody's mouth, take out a 2. Okay. So once I take the 2 out, now it's just a diamond. What multiplies to negative 3 and adds to negative 2? Negative 3 and 1. and you set each of the sets of parentheses equal to 0. That 2 now kind of just, So x is 3 and x is -1.
So nothing happens with this one?
Nope. If there was an x with it, we'd do something with it. But just a number, nope. It just sort of like, And since neither 3 or -1 causes those to become a 0, I actually end up with 2 answers. Okay, and they both work. So now, there is only one last thing left to deal with. Okay, and this is the easy stuff. Yeah, we don't even have to mess with common denominators now. Yay! Actually, I'm going to bring this back out a little bit. So just a second here.
Wait, where's foil?
Yes.
Oh no.
Thank you.
What did I do? When you're going to cross multiply, just a suggestion. Any place that you see plus or minus, I would put parentheses in right away, and here's why. Some of you, when you go to cross multiply, this would end up being 2x minus 5, and this would be 4x plus 3. You'd totally forget about the entire idea of, oh yeah, it distributes through. So when I go here, I've got 2x, 2 times -5, would be minus 10.
Oh, we're doing 10. So we're doing.
Yep. And then 4x plus 6. And just solve it.
Isn't the answer?
I'm cross multiplying. And when you cross multiply, that distributes to both terms, working each side. So now, I'll subtract the 2x over. I'll minus the 6 going the other way. And I'll get me an answer. And again, as long as I don't get a 0, I'm good. So you don't have to physically put it in and find out the exact answer to see if they match. It will. Just checking the bottom. Just checking the denominators to make sure we don't get 0. Because that's a problem. Now, before you panic on 12, it is not going to be anything like number 9 was. When you cross multiply and FOIL this out, okay, I will even help out and tell you what you are going to get. Okay, so my initial cross, and it doesn't matter which one you do first. Okay, so that'll be my initial one going this way. And when I come this way, and if I have to do some side work, I will show it. Yes, it does. How did I get the 43?
Very good.
Okay. If I'm doing this, you got something totally different. Okay, let's see.
I just did 3 times 4 and then.
So when I go and I start distributing, I start foiling this out. So then I've got 12x squared, -39 and -4 is -43x plus 13. So that's where this is coming from. Yep. And so then, oops, I lost my x over here. So, here's the good news. When I try to get all the x squareds together, what happens? They explode, yes. Okay? They cancel. So now, but remember, when we cross multiply, no denominator to even play with. Because here, notice, I'm not adding and subtracting anymore. I'm just multiplying. That's why I don't have to mess with that anymore. So, all my x's to one side, all my constant terms to the other, and divide.
I think 32. I said 23 there.
Now,
It's 3.
does 1/3 cause a problem?
How did you get?
What caused the problem?
Oh, the 23 line.
Oh, 1/3.
Yes. Yeah, be cautious. Your eyes are going to tell you something. Your brain's going to tell you something different than your eyes are. A lot of you are going to see 69 and 23 and go 69 divided by 23 is 3. And then I'm going to go, no, because the 69's with x, you have to divide by that. It's going to be a fraction.
I don't like this.
Again, detail. But again, let me come back to the question I was asking before we hit that bump.
Yeah.
Does 1/3 cause a problem? Yes. 1/3 of 6 is 2. 2 minus 2, uh-oh.
We have no solution. How did you figure that out?
How did I figure out it's no solution? Okay, if I plug in 1/3 into either of these denominators, if I get a 0 out, that's a problem because you can't divide by 0. So 1/3 of 6 is 2. 2 minus 2 is 0, so that's a no solutioner. So here is our maybe task at hand. Let me move this sticky note and replace it with a new one.
Yay.
I thought the back was
No, ignore the back of this note sheet.
good. Are we only gonna do it?
No, ignore the back of this note sheet.
So I could like color it black.
Yes, you can color it black, you can scribble, you can make things explode, whatever you want to do. Okay? Work on these tonight because tomorrow there is a worksheet coming behind it. Do not procrastinate.
When is homework for Brandon?
Homework check is Monday.
Are we gonna go over the packet for
For the test, we go over that Monday. It's not in the homework check.
the? Would you be having